And Dr. Zhang, please share your screen to start. Thank you.
Can you guys see my screen?
Yes.
Okay, cool. I can start.
Yes, you can start.
Sure. Okay, good morning, everyone. My name is Hang Li. I'm a PhD student working with Dr. Jiansong Zhang at Purdue University at Automation and Intelligent Construction Lab. My topic today is about IFC-based information extraction and analysis of HVAC objects to support building energy modeling. Okay, let's get started. There are 7 sections in my presentation today. I'll start with the problem statement and the model collection. Then I will give our proposed methodology and the implementation of the methodology on the collected model. Following that, I will show a case study, and finally, I will show the conclusion and the limitation and future work. Now let's get started. So traditional energy evaluation approach is time consuming, and engineers and designers would heavily rely on the 2D mechanical drawings for the HVAC information analysis as a standard industry practice. So this will result a lot of labor hours to manually extract HVAC information from 2D drawings. In this case, automation is a necessary step. And the building information model can provide building information, including geometry, material, space, as well as HVAC systems. So in order to automate the information extraction, we collected 2 beam models in IFC formats. The first model is the duplex apartment building model, as shown in Figure 1, and the second one is the office building model, as shown in Figure 2. And each model consists of 2 sub-models. The first one is the architecture model, defining the geometry, and the second one is the MEP model, defining mechanical, electrical, plumbing systems. And we summarized the number of HVAC-related entities in the Table 1, Table 2 for the 2 models respectively. As you can see, the duplex apartment model has boiler, radiator, pump, and the office building model has screw chiller, air handling unit, VAV unit, etc. Okay, so our proposed methodology consists of 4 steps. The first step is to identify HVAC system type, then extract HVAC loops and the components. And third step is parse detailed parameters. And finally, identify related thermal zone for each HVAC terminal. So now I'll show the implementation of our proposed method on the collected models. So the first step is to identify HVAC system type. Basically, the system type was identified by the IFC energy conversion device entity. The table 3 shows the IFC energy conversion device representation and the corresponding system type. As you can see, the 2 models, the duplex apartment building model is identified as a hot water boiler system, and the office building with chiller is identified as a VAV system with chiller. And we also summarized the corresponding IFC entities for HVAC components, for each HVAC component in Table 4. Basically, boiler, radiator, chiller are represented as IFC conversion device, and the pump, VAV unit, AHU are represented as IFC flow moving device. Okay, the next step is to extract HVAC loops and components. The loop extraction is important because it defines the relationship of HVAC components between each other. For example, The figure 4 shows the two hot water loop extracted from the duplex apartment building model. And as you can see from figure 4A, the boiler A is serving for the 7 particular radiators and by providing the hot water. So by extracting the loop, we can know the relationship between the boiler and the radiator. And further, the radiator will serve thermal zones correspondingly. Similarly, for the office building model as shown in figure 5, there is the chilled water loop and the air loop. The chiller will provide chilled water to the air handling unit, and the air handling unit will serve as a heat exchanger, providing cooling energy to the air loop. So the system, the loop extraction is basically done by a classification algorithm we developed by parsing the keywords. For example, here, unit A, hydronics fly-in, and unit B, hydronics fly-in is to distinguish the two hot water loops. Okay, the next step is to parse detailed parameters for each HVAC component. Basically, there are two ways in IFC data structure to define the parameters of each entity. The first way is to define the basic parameters through the .getInfo method in the IFC data structure. So as you can see from figure 6, there is a screw chiller and cooling capacity defined in this entity. And the second way is through the IFC property sets that entity instance related to that particular HVAC components. So we can extract the mechanical properties of each HVAC component through the mechanical IFC property sets. As you can see from figure 7, we extract the pressure drop, water flow rate, and cooling capacity here. So this table 5 summarizes the extracted parameters of the hot water boiler system for the duplex apartment building, including boiler, radiator, pump, which is the 3 main components of the HVAC system. And we extract the capacity, pressure drop, efficiency for each component. Okay, the final step is to identify related thermal zone for HVAC terminals. So this is basically done by extracting the IFC real contained in spatial structure entity, which defines the relationship between HVAC terminal to each space or thermal zones. So as you can see from the figure 8, the purple box shows the space and the yellow box shows the radiator related to that space. And the figure 9 shows the sample of extracted thermal zones for the diffusers, which is for the VAV system from the office building model. I only show the sample because there are a huge number of spaces in the model. Now, let's move on to a case study. So the information extraction algorithm we developed by following the proposed methodology was tested on the testing model, a commercial building with 4 stories in Revit, we created in Revit. And table 6 summarized the testing results of the information extraction algorithm. There are 396 entity instances were successfully extracted without error. So we done this basically comparing the number of entity instances in original IFC model and the corrected extracted entity in the through the developed algorithm. Okay, to conclude, we proposed a 4-step methodology for parsing and extracting HVAC information from the IFC-based building information models. And 2 types of HVAC system were investigated following the proposed methodology. The HVAC information extraction algorithm was also tested on a commercial building model with the boiler radiator system and achieved the error-free extraction. And this is expected to help reduce the time and effort in the information extraction of HVAC systems from BIM compared to that by manual extraction from 2D mechanical drawings. And the extracted information can also support creating energy model in our future step. So some limitation and the future work. This work is only focused on the high-level extraction following the 4 steps, and the HVAC system is still limited to boiler system and the VAV system in the 2 cases, and also air distribution components and detailed parameters, as well as the control strategies has not been extracted yet, and a more comprehensive and robust algorithm can be developed in future work. Finally, automated methods implementing enrichment of IFC-based BIM and model and validation checking could help facilitate the IFC-based BIM interoperability with building energy model. Okay. Thank you. Any questions?
Yes, thank you. Anyone have any questions to ask? Anyone from the site?
So you reported 100% accuracy for all categories. I imagine that's because of how clean your data was. Mm-hmm. So the question is, if you were to expand your data set and deploy this more widely, maybe on data that wasn't so carefully created, could you maybe try to predict some of the main failure modes of this method?
Right. That's a good question. Yeah, I think some of the failure can come from different representations in different version of IFC data schema. And also, we only explore some main HVAC components in the IFC model. Some control entity instances were not explored yet. So the failure can come from these ways, and but I think we can address them by feeding more of the development data by collecting more models in the training or to improve the extraction algorithm. Yeah, hope that helps.
Yes, thank you.